Wear sunscreen. If I could offer you only one tip for the future, sunscreen would be it. The long-term benefits of sunscreen have been proved by scientists, whereas the rest of my advice has no basis more reliable than my own meandering experience. I will dispense this advice now. Enjoy the power and beauty.
So, do you know the song of the speech? Wear sunscreen. So, why I'm going to have you listen to this? So, actually, the origin of this speech is fascinating. But what is important to me tonight is what the speech says. As you heard, you can guess that he's going to give advices to young people. Actually, this speech took inspiration for a column from the Chicago Tribune. The title was Advices and Youth Are Wasted on the Youth. So in this speech, the speaker gives advices, but not much with much unreserved convictions. He knows, actually, that those advices are born from his own experience and are just opinions. But there is one firmly held belief: wear sunscreen. Because the speaker knows that is no opinion. It's actually an advice based on a thorough scientific investigation that have proved beyond doubt the damaging effects of sunscreen, of the prolonged exposure to sun for our skins. So this is in a nutshell why I decided for a career in science. And I will be more specific in a second. But actually, this is contrary to my beginnings. I started as actually, I enrolled myself in I started studying art, applied art, for 2 years, and then I switched to a high school in foreign language and literature, and was a very elitarian high school, extremely challenging. All my schoolmates actually, at the age of 18 and 19, decided to go on a career in humanities. But I stepped aside, and I decided to do a bachelor and a master in physics. This is because actually, among the chaos of opinions and random accidents that make up most of our path in life, science for me had the reassuring feeling of a firm thread on which I could step on to reach and satisfy, at least partially, my unextinguishable curiosity of how nature works, and to get answers that are supported by facts, quantitative answers, to simplify a yes or a no, but not a maybe or I wish or it's my opinion. So, welcome tonight to where my curiosity brought me, to space, and in particular to hypervelocity stars. But what are hypervelocity stars? Now I'm going to say a sentence. So hypervelocity stars are stars with extreme velocity launched from the center of our galaxy to the outskirts, and that can be used to trace dark matter. So the goal of my talk tonight is to explain each of the words I just said in this sentence and also the overall meaning. Let's see if I can. Okay, so let's start. So what's our galaxy? What is our galaxy? So if we could actually fly outside of our galaxy, the sun is here, and we could see our galaxy edge-on, it would look like this. So it's a thin disk edge-on of 100 billion stars and gas and dust. And these stars, they move in a sea of gas and dust, but not in a random way. Actually, they form a beautiful spiral pattern. And in the middle, a concentration of stars, they move roughly like this. But they stay close to the galaxy, okay? But what we see here is just what our telescopes allow us to see. But this is a tiny fraction of the total matter of the galaxy. Most of the matter in the galaxy is actually dark. And, sorry. Yes, finally, I have my dark matter. So this is the visible light, so the stars and the gas, but this matter around this is dark. We cannot see it, we can feel it. I know it sounds creepy, but we can feel it because of the gravitational attraction, the gravitational pull that moves other stars around, moves the gas around, and certainly draws me towards understanding what dark matter is. But what is the center of our galaxy? I said that the hypervelocity stars, they come from the center of our galaxy. Have you ever seen the center of our galaxy? I think some of you have seen it. If you have seen the Milky Way, this stripe of shimmery bright stars in the dark skies, then you have peered towards the galactic center. The galactic center is here. And just a curiosity, this, as you know, is called the Via Láctea, but galaxy has the same meaning. So when we say the Milky Way galaxy, we're actually saying Milky, 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 Milky. And this is just because this beautiful astronomical phenomena gave the name to the galaxy and to all galaxies. Okay, so let's dive into it. So this is a beautiful movie in which we are diving towards the center between the Sagittarius and the Scorpius constellation. And between us and the center, there are a lot of stars, billions of stars, and gas and dust. And Gaia cannot see through it, actually. It's too opaque. But telescopes have spent hours and hours to try to find what is hidden at the center of the galaxy. And at the beginning of the 2000s, we discovered a surprise, a really magnificent surprise. These are our observations of the closest stars that we can observe at the center of our galaxy. Let's look at this observation closely. So scientists, theoreticians like me, have modeled the motion of these stars. This is a computer animation, a calculation. And they have modeled the motion of the stars, and they have discovered that the only way they could account for the collective motions of stars is if at the center there was a massive black hole. So you don't know, but at the very core, or maybe you know, but at the very core of our galaxy lies a 4 million solar mass black hole. What does the black hole can do for us? Oh, for me, lots of things. For instance, if you take binary stars, two stars that are linked together by gravity and they rotate, Jack Hills in 1988 actually, as a visionary, I think, imagined what could have happened to such a binary stars if we would encounter a supermassive black hole. And he worked out mathematically that one of the two stars would remain bound to the black hole. The black hole would retain the star, catch it, and the other star would be kicked out at a very high velocity. Have we seen these stars? Actually, yes, I just showed you. These are, we think, are the stars that we have observed, whose trajectories tell us beyond doubt that there is a supermassive black hole at the center of our galaxy. This is actually the best and direct detection of a supermassive black holes that we have in the universe so far. And of course, the star that's been kicked off is my dear hypervelocity star. So this star starts from the galactic center and then has such a huge velocity that can leave the galaxy and fly into the region that is, dominated by dark matter. The first star, the first hypervelocity stars were discovered in 2005, and given its huge velocity, larger than the escape speed of the galaxy, which means that these stars will leave the galaxy forever, really caught the attention of the media. And I really liked this cartoon from the New York Times, in which there is a black hole which literally kicks a star out of the galaxy. So this is very nice and I think quite true. Okay, so why I like hypervelocity stars? Because as I said, they can feel dark matter. So these stars are very fast runners, but they have to run against dark matter that wants to decelerate them, pull them back. If with my hypervelocity stars I can measure this deceleration, I can quantify how much dark matter there is in our galaxy, but also the distribution, if it's smooth, bumpy, and this will tell me something about the formation of my galaxy, because if we want to understand the universe, we have to understand dark matter, because dark matter is the most is the kind of matter that matters, I guess. Most of the matter in our universe is dark. That's what I try to say. Okay. So far, we have observed only, not me, actually, people in Harvard has observed only 20 hypervelocity stars. This is not enough for my experiments. I need more stars, but luckily Anthony have provided me with Gaia. Gaia, he showed you beautifully, can trace stars in the sky. And so, of course, can pick up my fast runners, okay? There is only one small problem. Gaia is going to deliver proper motion and parallaxes. I said parallaxes. Now you know what the parallax is. I said parallaxes and proper motion for 2 billion stars. 2 billion stars is 1,000 billion stars. So this is the biggest catalog of stars that the humankind had ever collected. And how many hypervelocity stars will be in there? Actually, just 1,000. So I need to find 1,000 very rare stars in a huge catalogs of 2 billion stars. Okay, so I need help. Okay, and now sounds science fiction, but actually what we decided to do is to use artificial intelligence to construct an algorithm that actually mimics the human brain. And here there is the creator, Tommaso, somewhere over there, of this algorithm. But what this algorithm is really mimic the way we learn by experience. Okay, I'll give you an example. You're walking with your baby daughter, and she sees for the first time a dog. And so what would you say? Woof, woof, this is a dog. And she looks at you and says, okay, she's not crazy. Okay, I understand. Woof, woof, fine. And then we meet another dog, and mommy says, woof, woof, this is a dog. And she says, it's completely different. Is it a dog? Okay. And then chances are that the third time that we meet a dog, and this is yet a completely different one, very cute. Maybe I should give a talk on dogs. Then if we meet for the third time a dog, a completely different dog, chances are that she tells me, woof, it's a dog. Not it's a dog, but woof, woof. She has learned what a dog is, and she has learned to recognize it among all other animals. And she didn't need to see all different type of dogs. She just needed a few examples, and she learned. So that our algorithm does. So we gave to the algorithm a few examples of hypervelocity stars, how they are distributed, and the algorithm learned to find a hypervelocity star wherever it is in the sky. Or at least we thought it learned. We had to test it, right? So Anthony told you that last year, Gaia released the first catalog, just 2 million stars. Still quite impressive. And the very same day, Tommaso applied this algorithm straight away, and we were anxious to see whether it worked. Did it work? Of course, otherwise I wouldn't be giving this talk. Yes. And this is the ESA press release of what our algorithm found. Okay. So what is impressive, is still impressive to us, is that the algorithm managed to detect among these 2 million of stars a few very high velocity stars, 5 of which, look at this one, 5 of which are actually consistent with coming from the galactic center. So our algorithm learned that among these animals, this is a dog. And now we are waiting for the second data release, the one with 2 billion stars, and I hope to find many of these, and I will come back to tell you more about what we find in dark matter. Thank you.